Use. China claims U architecture using 14nm logic and 18nm DRAM could match NVIDIA's 4nm GPUs. Under tightening U.S. export restrictions, China is turning to the innovative chip architectures to bolster computing capabilities, according to the South China Morning Post. This strategy, pairing mature node chips with the novel system designs, aims to narrow the performance gap with NVIDIA. South China Morning Post cites Wei Xiaojun, as vice president of the China Semiconductor Industry Association, who argued that 14nm logic chips, when combined with high-performance memory and an advanced computing architecture, could approach the capabilities of NVIDIA's 4nm AI training processors. He further emphasized that his proposed framework is built on a fully homegrown supply chain. Wei's approach centers on software-defined near-memory computing and 3D hybrid bonding to stack the 14nm logic dies with 18nm DRAM. The near-memory computing places processes closer to memory in a hardware-software co-design to reduce data movement and improve efficiency, the report adds. Thomson hardware notes 3D hybrid bonding, copper to copper and oxide bonding, which replaces solder bumps with direct copper interconnects at sub 10 micrometer pitches, as a key element of the proposed design. The solution also seeks to reduce market dependence on NVIDIA's CUDA ecosystem, according to the Commercial Times. Wei identified CUDA as a major point of vulnerability, and noting that once software, models, and hardware becomes tied to a single proprietary platform, deploying the alternative processors becomes exceedingly difficult, as noted by Thomson Hardware. Chinese outlet POP indicates that Wei had disclosed additional performance claims, stating that the domestic design achieved 2 teraflops per watt and a total of 120 teraflops, figures he said surface NVIDIA's A100 GPU. However, official specifications show that the A100 reaches up to 312 teraflops, well above the Chinese solution's capabilities. The concept of using stacking design to offset limits in process technology is being echoed by the Chinese tech leaders, according to South China Morning Post. Hardware founder and Ren Zhangfei argued that China can reach cutting-edge performance through chip stacking and clustering without engaging in a direct node-by-node contest. Okay, next one is from Synopsys. Adapting foundation IP to exceed 2nm power efficiency in next-gen hyperscale compute engines. Competing in the booming data center chip market often comes down to one factor: power efficiency. The less power a CPU, GPU, or AI accelerator requires to produce results, the more processing can offer within a given power budget. With data centers and their commensurate power needs growing exponentially, the energy consumption of each chip directly impacts the enormous cost of running gigawatt-scale AI data centers, where the power and cooling account for 40 to 60% of operational expenditures. To reduce the energy consumption of their workloads and gain a competitive edge, one software and cloud computing titan has made a strategic bet to design their own next-generation hyperscale system-on-chip SoC. By combining the advantages of a new nanometer-class process node with advanced, customized chip design techniques, the company is doubling down the belief that the innovation spanning process, design, and architecture can unlock new levels of the power and cost efficiency. Power play. To offer a compelling alternative in this market, the company knew that any new 2-nanometer design must push beyond the performance and efficiency process entitlement already baked into the scaling factors of the latest transistor fabrication method. The transition 2-nanometer process is expected to provide 25 to 30% power reduction relative to the previous 3-nanometer node. So the company set an ambitious goals of achieving an additional 5% improvement on a 2-nanometer baseline. So through the close collaboration with Synopsys, combining EDA software flow enhancement with our optimized foundation IP logic library, the company exceeded their goal, achieving 7.34% reduced power consumptions with the same baseline flow, and 9.51% reduced power consumption with an optimized flow. 7.5% silicon area advantages over baseline with iOS performance. So the company also evaluated our 2-nanometer embedded memory, which exceeded SRAM scaling expectations compared to our 3-nanometer product. On average, the 2-nanometer memory instances delivered 12% higher speed and occupied 8% less area and consumed 12% less power than their 3-nanometer counterparts. So the expert collaboration. Because the transition to 2-nanometer comes with a shift from a FinFET to GAA architecture, the company's SoC developers faced a particular steep learning curve with an increase in complexity and technology assimilation. They engaged our team in early stage of the project by the product of the trusted working relationship that spans more than 4 generations of AI chip designs, and even a license to our foundation IP prior to the availability of any silicon reports. The company used our IP reference methodology and a Fusion compiler tool to explore all commercially available options for achieving their power budget requirements. While the early development cycles produced the silicon area advantages, they did not achieve the power scaling target the company sought. Adaptation and optimization. Seeking additional assistance, the company required whether our EDA tools and IP could be leveraged to push the design performance further. R&D experts from our IP and EDA groups began collaborating on the design, starting with the standard logic libraries, and the IP group worked closely with the company's designers to adapt and optimize the libraries with the new cells and updated modeling. Over several iterations, the teams delivered the 7.34% power benefit with Synopsys prime power used for final power analysis. So our technology and product development group then helped the company take it a step further by developing the new algorithms for a Fusion compiler, and after many trials based on the latest recommended power recipe, design flow optimizations produced the 9.51% combined power benefit. So at the same time, our application engineers worked closely with the company to provide the best solution from our broad portfolio of memory compilers, weighing performance requirements with power and area targets. We are able to extend the benefit of a 2-nanometer beyond the instance level scaling. In one key scenario, power was reduced additional 25% by using an alternative configuration that met a 2 nanometer requirement. Team effort. Developing a hyperscale SoC and the most advanced process node pushes engineering teams harder than ever, and the company, the stakes couldn't be higher. And not just about investment, it's about securing a competitive edge in a fast-moving market. With so much riding on a power target, we are proud the company trusted our proven expertise to help deliver their next-gen SoCs. Next one is from Cadence, the power of shifting left. Cadence accelerating innovation with the ARM. In semiconductor design, projects are remembered their extremes, legendary successes, and cautionary failures. The difference often hinges on when problems are discovered. A bug found late in the development can derail timelines and budget. This is why shift left. Moving testing and validation earlier in the process is now a critical strategy for innovation. Why shifting left matters. Shifting left means bringing testing, verification, and validation activities forward the design cycle. Instead of waiting for physical prototypes, teams use simulation and emulation to catch issues early. This proactive approach reduces costs, accelerates time to market, and minimizes the risk of the late-stage surprises. The cost delta is staggering. NASA's research shows that the cost of fixing a bug multiplies tenfold at each stage of the development. A bug caught during requirement costs 1x, 1 times, during design 10 times, during build 100 times, and in production 1,000 times. That is real money, real time, and real risk. Cadence's approaches to IP integration at Cadence, we've made shift lefting a core part of our IP delivered models. Take PCI Express technology. Previously, customers received a separate controller and file component and were left to sort our integration challenges themselves. We changed that by delivering a pre-verified subsystem controller and file tested together in a real environment. We own the integration risk, not our customers. We apply this industry standard to emerging technologies such as CXL and UCIe. The ARM, the Neoverse CSS ecosystem blueprint for acceleration. ARM, the Neoverse Compute Subsystem CSS, take this approach further. Going beyond the discrete IP, ARM delivers a pre-integrated, pre-verified platform, cores, mesh, and control logic, all ready to go. The solver-based system architecture, SBSA, and system-ready compliance to mean hardware boot out of the box. This robust framework eliminates the bottlenecks and accelerates system bringer. Cadence and ARM, multi-platform validation for real-world success. As a key ARM partner, we provide next-generation IP for integrate interfaces such as PCIe, CLX, and DDR memory. Our multi-form validation pipeline embedded shift-left as follows. RTS simulation with XLM logic simulation. Early sanity checks catch the fundamental issues in PCIe transactions and memory operation. Emulation with Palladium solution. High-speed and hardware-based emulation runs through ARM system-ready validation suites, stress testing systems before silicon exists. Full compliance testing. Rigorous multi-stage stage testing ensures our IP meets SPSA and system-ready specifications, giving customers confidence from day one. What truly sets this collaboration apart is the depth and the breadth of our validation strategy. By leveraging both simulation and emulation, we replicate the real-world scenarios and workloads, uncovering edge cases that might otherwise go undetected until late in the development cycle. This means our customers receive the IP that's not only functional or robust, but also proven to perform under demanding conditions. Our team worked closely with the ARM's engineers to co-develop test plans, share insight, and rapidly iterate on our solutions. The joint effort to accelerate the identification and resolution of integration challenges, ensuring that our IP seamlessly fit within the ARM nervous Never's CSS ecosystem. We also validate across multiple platforms and configuration, from basic boot sequences to complex memory and connectivity operations, so customers can trust that their system will work as intended right out of the box. Some interfaces, such as PCIe and DDR5, require special attention due to the legacy quirk and boot requirements. Cadence integrates and validates these within the ARM, the Nervous CSS environment, ensuring robust and low-risk solutions for customers. So this comprehensive collaborative approach is the foundation for delivering the innovation and speed and scale. The future, collaborative, accelerating innovation. The ongoing collaboration between Cadence and ARM is continually evolving. As a new ARM Nervous CSS versions and a protocol standard merge, we co-validate solutions to stay ahead. Test chip featuring Cadence IP and ARM cores validated functionality in silicon, shifting left before customers even start their designs. Whether through the leading-edge IP, full subsystem integration, or cloud-based validation, Cadence is committed to customer success. By embracing the shift left and collaborating with the ARM, we were building not just better components, but faster, more efficient path to innovation. Okay, next one is from electric to telegraph to FPGA prototype Siemens journey of innovation. The reading time. The growing up in Germany in the 1960s, the name Siemens was everywhere. It stood for reliability and innovation and quality, whether it was kitchen appliances, electronic trains, traffic light and X-ray machines, or light bulbs. Later, Siemens become synonymous with mobile phones, communication equipment, and computers. Through its more than 175-year history, Siemens has always been a company that innovated and transformed the industry. Today, Siemens is a global leader in power generation and transmission, medical equipment, and industrial smart infrastructure solutions. But for many years, there was an array where Siemens did not have a significant presence: electrical design automation, EDA, and semiconductor design. That changes in 2017 with the acquisition of Mentor Graphics, a major milestone that extended Siemens' innovation footprint deeply into the semiconductor space. With Mentor came a portfolio of advanced tools and technologies essential for today's AI and software-driven world, particularly in hardware-assisted verification, which includes emulation and FPGA-based prototyping. Software defined product success. Today, software often determines whether a product succeeds or fails. Think about the smartphone in your hand or pocket without a software and apps. It would be little more than an expensive paperweight. Software also dominates design cost and schedules, which is my wide efficient verification platforms are critical. This is where emulation and FPGA-based prototyping make all the difference, enabling teams to validate hardware and software long before silicon is available. The Siemens advantage is in hardware-assisted verification. Siemens is now the only one of the big three EDA companies with a comprehensive hardware-assisted verification portfolio. Our Veloce CS platforms include Veloce Stratus CS, a custom chip emulator, Veloce Primo CS, an enterprise-level emulation congruent prototyping system, Veloce Pro FPGA CS, as a high-performance FPGA-based prototyping system. Among these platforms, the newest Veloce Pro FPGA CS best embodies the speed, agility, and innovation Siemens brings to our customers. Introduced Veloce Pro FPGA CS and powered by the AMD VP1902. Built on AMD's latest Versa adaptive SoC, the VP1902, the Veloce Pro FPGA CS redefines FPGA-based prototyping. Siemens was the first to begin the shipping production system starting in August 2024, just weeks after the VP1902 became available, and well ahead of anyone else in the industry. Veloce Pro FPGA CS leads the way with its innovative features that boost productivity and usability, including flexible configuration from a single FPGA, Uno setup to the multi-blade rack system with hundreds of FPGAs, and unparalleled I/O flexibility. Virtually every FPGA I/O is available to the user, enabling the highest possible runtime performance. Robust engineering, built to the highest standards and deployed workload across the thousands of systems. Empowered by software, the Veloce Prototyping Suite, VPS. Of course, hardware alone isn't enough. The real power of, I'm sorry, today I should finish it and I will lead the next thing. And today, thank you for your time. See you next time.